Hello and welcome to Unit 4. We're going to start off by using a lot of quadratics. So we're going to try to solve a quadratic formula, which again is our little horseshoe graph. So let's get started. So we always kind of like to start with what does it mean by solving? And so that's what we're going to do. That's what we're going to start off with. So it says solutions to a quadratic equation. So we've got the solution to a quadratic equation are the points at which the function intersects with the x-axis. So we call them zeros. So x-axis. So again, where the graph crosses the x-axis. So the solutions are also referred to as zeros, roots, or x-intercepts. So those are all they mean the same thing. So zeros, roots, or x-intercepts. Again, they're just different ways of saying where does the graph cross the x-intercept. So if we were to look at a picture, so most of the time you're going to have two solutions, and that is because your graph is going to look something like this. So it crosses the x-axis at 2 points. So that's where you get the x squareds. You usually can have a positive or negative. But again, it's just the graph crossing the x-axis at 2 points. You can have one solution. That's when the vertex itself is on the x-axis. You can also have no solutions, no real solutions. So that would look something like this, or something like this. Notice how it just never actually crosses the x-axis. So these are all possibilities. Again, the two solutions is going to be your most common, but the other two will happen. So let's try some examples. So for our first couple examples, all we're going to do is solve by graphing. So we've learned a variety of different ways that we can graph. There's kind of what I like to call the spray and pray method, where you just throw points at it and see where they land. We can be a little bit more strategic than that. We can use the vertex method. So if I were to just do part of the vertex, I just want to know where it starts. We could do the whole completing the squares thing. So 2 divided by 2 is 1, and then that squared, we're going to have x squared plus 1. That means that our vertex, and of course there's other stuff here, but I really don't care about that. I'm just going to set up a chart, and I just kind of want to know where to start. So if we do our XY coordinates, we've got a vertex at -1. So that means that our x is at -1. So we can plug that into the function. You can either set it up in your calculator to do a table, you can graph it on your calculator, or you can do it by hand by plugging in x equals -1 everywhere where you see an x. So whatever method you have available to you, feel free to use. In this class, you'll always have a calculator, but maybe on the ACT or something like that, you might not. So you can always plug points into a graph, and you can graph it that way. But we know our vertex is at -1, so when we plug that in, we're going to get -4. So then if we go down a couple points, 0, 1, that's probably enough. We'll do 2, just for fun. So then we'll go the opposite direction, -2, -3, -4. So then if we start plugging those in, like I said, you can either do it by hand or by a calculator. I kind of already did the calculation, so you guys don't have to watch me stick it into a calculator. So then 0, -3, 1, 0, and 2, 5. So at this point, these are all points. We're just going to graph them onto our coordinate plane over here, and we're going to see where it crosses the x-axis. So we had mentioned that, where was our vertex? This was our vertex. So we'll start there, negative 4, 1, I'm sorry, negative 1, 1, 2, 3, 4. So there's our vertex. So then we got 0, negative 3, 1, 0, and that's as far as I need to go. So then negative 2, negative 3, and then what is that, negative 3? So then when we graph it, it's going to look like that. We've got our 2 points, which are right there. And so that is going to be, let's see here, negative 1, 2, 3. Negative 3, 0, and 1, 0. So this is our answer, or that is the solution, which means that the graph crosses the x-axis at those points, or the solution of the equation is negative 3 and 1, or the x-intercepts, the zeros, all those things kind of mean the same thing. All right, next up, same game. We're just gonna pick some points and we're gonna graph off of that, but we're gonna be a little bit strategic. We're gonna try to sort of do a little bit of research, figure out where the vertex is. So if we look at this up here, so it's got a negative sign in front of the x squared. So that tells me already that the graph is pointed down. Remember our transformations and things like that. Let's get rid of those. So we can pull that negative sign out, and then we've got x squared plus 10x plus 25. If we take half of 10, I don't want to write it like that, but if we take half of 10, it's going to be 5, and we square that, we're going to have 25. So we actually this is already factorable, and we could put it in vertex form. But either way, our vertex is going to be at negative 5. So that's just kind of good to know whenever we set up our XY chart. So in the middle here, we're going to pick negative 5, and then we'll go up a couple, negative 6, negative 7. We'll go down a couple. Technically it's the other way around, but whatever. So then, again, you're just going to plug these values into your equation. You can do this through the y equals function on your calculator, and then using the table. That's probably the easiest way to do this. You can do it all by hand if you're taking a test that you can't use a calculator. But either way, you just plug these numbers in for x. So here we go. So negative 7, negative 4, negative 6, negative 1, negative 5, 0, negative 4, negative 1, negative 3, negative 4. So again, this is going to be our vertex. And okay, so let's graph. So negative 1, 2, 3, 4, 5. That's our vertex. Remember, our curve is going down because of this negative sign. But let's see here, negative 6, negative 1. And then, we'll do negative 3, negative 4. 1, 2, 3, 1, 2, 3, 4. And I know it's going to be the same on this side because that's how parabolas work. I completely missed. So this is a situation where we only have one solution, one root, 1, 0, one time where it crosses the x-axis, one intercept. So our answer, our solution, is just going to be negative 5, 0. That's it. Only one solution. So let's try one more. Again, we're just going to do our xy table, but first we want to find the vertex. So we divide this by 2 and then square it. So 6 divided by 2 is 3. then we're going to square that. That is our 9. And so then when we, how do I go back? There it is. So then when we rewrite that, that's going to be like x minus 3 squared, and then plus and minus some other stuff, but I really don't care about that stuff. I just wanted the vertex. So we're going to start at positive 3. It's the opposite of that one. So that at least gives me a place to start. Again, if you plug this into your y equals function into your calculator, and then you can use the table, that'll do this part of the problem very easily, so you don't have to go through every single part. Anyway, so what did I say? The vertex is at 3. So we'll go up 2 or down 2, and then up 2, 4, and 5. So again, plug this stuff in your calculator, get the answer. Your answer should look like this. And so then we're just going to plot those points, and we'll see where it lands. So we're going to start with our vertex. Is at 3, -1. 1, 2, 3, -1. We go over to the right, so that's 4, 0. And then 5, it's gonna be right there. I'll go up 3, 1, 2, 3. So we have our solutions right there. We are going to have 2 points. So we've got, what is that? X, Y. So that's 2, 0. Yes, I forgot which one my X and Y's were for a second. And 4, 0. So your answer is going to be the points 2, 0, and 4, 0. Or the zeros of the function is 2 and 4. Whatever, again, all these different vocabulary words means where does the graph cross the x-axis? Okay, looking at 4, 5, and 6, why don't you try those out and see if you can get the right answer? So here we go. So here's the work that I did. Did you get -7 and -4? If so, good job. If not, try it again, figure out where you made your mistake. This vertex, I will admit, is a little weird, but doesn't have to be plotted in the exact right point, and the places that it crosses the graph is still an easy or a kind number to find. We'll call it a kind number. So let's try number 5, see if you can do that one. Did you get it? I got the vertex at 0, -9, and I plotted some points, and I got my solutions at -3 and 3. Okay, the rest of those you can try on your own if you want. You'll also be doing a decent amount of them on your practice homework or your practice work, so either way. I wanted to spend a little bit of time reviewing everyone's favorite thing called factoring. So factoring is very important, and it actually makes solving quadratics a lot easier, and we're going to be using it for this whole unit. So we have to remember how to factor. Also, this is one of the most forgotten things that students struggle with when they're taking college algebra, taking math placement tests, whatever. People forget how to factor. So let's do some factoring. So step 1 in factoring, always, no matter what, is finding the greatest common factor and factoring it out. No matter what, when you're trying to factor, you will always start with that process. So when you look at number 1, so you can see 12 and 18, they both have a multiple of 6 in common. If you didn't see that immediately, because 6 times 2 is 12, 6 times 3 is 18, That's okay. You just need to develop some strategies to find them. So I don't see that stuff very well either. So I would look at that and immediately go, okay, I can pull a 2 out. So I can pull a 2, and then we would have 6k minus 9 left over. Okay, so there I can see a 3, so I can pull a 3 out. So then when that comes out, we're going to take 3 times the 2, and then we'll have 2k minus 3. And there, I'm now confident that this is now factored. So either method works. If you can see the greatest common factor immediately, pull it out. If you can't, find tips and tricks. So for example, if both numbers are even, you can pull 2 out, okay? There's also a trick for 3. If you add the 2 digits together and it's a multiple of 3, then the whole thing is a multiple of 3. So for example, we take 2 plus 1, that's 3. 3 is divisible by 3, so I knew that I could pull a 3 out of that as well. And that works for all multiples of 3. So that's the 2 tips and tricks that I use to try to factor this stuff, because again, I don't see the big numbers immediately. I kind of have to work with the smaller numbers because they make me happy. Okay, number 2's got some letters in it. That's no problem. Again, you're just going to pull out the things that they have in common. So I'm just going to start with the numbers because to me that's a little bit harder. So the first thing I'm looking at, okay, they're both even. So I can pull a 2 out. So when I do that, I'm going to have 20, and then whatever 64 divided by 2 is, because I totally know that off the top of my head. 32, yeah, totally, 32. And I'm leaving some space for the letters because the letters are still there. I'm just not messing with them yet. 20 and 32 is still divisible by another 2. So then we're going to take another 2. So now we've got like 10, 32, 16. Yeah, I knew that. Totally knew that. Okay, they're still even. 10 and 16 are still even, so I can pull another 2 out. So now we're going to have 8. That's going to be 5, and that's going to be 8. 16 divided by 2 is 8. Okay, 8. Okay, so see how I did that? I used small numbers until I got to the final step. It's an extra couple of steps, but if you don't immediately see that an 8 is divisible by both 40 and 64, that is one strategy that you can use. It's a strategy that I use. Anyway, so the exponents, I think, are a little bit easier. We have 8x's over here. We have 4x's over here. So we can pull 4x's out because that is what they have in common. We got to move this whole thing over. So we can pull an x to the 4th. And they also both have one y in it. So we're going to pull a y out as well. So when we pull the x to the 4th, our first number has 4 x's left over. And then our second number has no x's left over. And neither one has any y's left over. So we're going to put our plus sign right there. And I'm going to rewrite it just to make it look a little bit nicer, because generally we like to have our number in front. X to the 4th, y times 5, x to the 4 plus 8. So there you go. We factored out the greatest common factor. Okay, number 2's got some letters in it. That's no problem. Again, you're just going to pull out the things that they have in common. So I'm just going to start with the numbers because to me that's a little bit harder. So the first thing I'm looking at, okay, they're both even. So I can pull a 2 out. So when I do that, I'm going to have 20, And then whatever 64 divided by 2 is, because I totally know that off the top of my head. 32, yeah, totally, 32. And I'm leaving some space for the letters because the letters are still there. I'm just not messing with them yet. 20 and 32 is still divisible by another 2. So then we're going to take another 2. So now we've got like 10, 32, divided by 2, 16. Yeah, I knew that. Totally knew that. Okay, they're still even. 10 and 16 are still even, so I can pull another 2 out. So now we're going to have 8. That's going to be 5, and that's going to be 8. 16 divided by 2 is 8. Okay, 8. Okay, so see how I did that? I used small numbers until I got to the final step. It's an extra couple of steps, but if you don't immediately see that an 8 is divisible by both 40 and 64, that is one strategy that you can use. It's a strategy that I use. Anyway, so the exponents, I think, are a little bit easier. We have 8x's over here. We have 4x's over here. So we can pull 4x's out because that is what they have in common. We got to move this whole thing over. So we can pull an x to the 4th. And they also both have one y in it. So we're going to pull a y out as well. So when we pull the x to the 4th, our first number has 4 x's left over. And then our second number has no x's left over. And neither one has any y's left over. So we're going to put our plus sign right there. And I'm going to rewrite it just to make it look a little bit nicer, because generally we like to have our number in front. X to the 4th, y times 5, x to the 4 plus 8. So there you go. We factored out the greatest common factor. Okay, so number 3, when we look at it, we've got a 14, a 35, and a 7. Oh, look, they are all multiples of 7. So we've got a 7, and then we're going to look at our letters. We've got an m to the 6th, m to the 3rd, m squared. So the most we can pull out is that m squared. So that is what we will do. We've got m squared. So then what do we have left over? Our 14 m to the 6th divided by 7m squared. It'll be 2m to the 4th. Remember, when we're dividing exponents, we're just going to subtract them. Minus 5m to the 1st. Don't need to write it. It's an insinuated 1. Minus 1. And there we go. All factored. So number 4, you try yourself and we'll see what we get. Hey, so apparently none of the numbers can be factored out, but that's okay. We got that A, B out. So hopefully you got something close to that. So factoring trinomials, this is when you've got 3 terms. So usually it's an x squared, an x, and a number. And hopefully you remember this, but this is where you're going to take multiples of this number, and they're going to either add or subtract to give you this number. So let's try it out. So if we look at 45, I'm going to do my notes over here off to the left. And the way I solve these things, like I have to use a calculator because I just don't know my times table as well as I should. But because this is a positive sign right here, that means that I know that both of my numbers are going to be the same sign. And then I look at this sign, and that's going to tell me what sign they are. So they're both going to be the same. They're going to be positive, and they're both going to be positive because of that guy. So I'm looking at my multiples. Okay, 1 is not useful. 2, that's not going to be good either. 3, I don't think that's going to work. Oh, 3 and 15. So we've got 3 times 15. If I add those together, that's not going to be 14. So then 45 divided by 5, that's kind of where I think we were going to get it. We got 5 times 9. So 5 times 9 is the 45. And then if we take 5 plus 9, that's going to give us our 14. So when we factor this, it's going to be x plus 5 and then x plus 9. So again, multiples of this number, add or subtract to give this number. Hopefully this is a little familiar. Let's try some more examples. So number 6, we're looking at this number, 26. We're going to look at multiples of that number. They're going to add together to give us this number, but both of those numbers are going to be negative because of that sign right there. So here we go. We can take 26, 26 divided by 2. We've got 2 times 13. And then we add those together, we are going to get that 15. But they're both going to be negatives. So I know that because a negative times a negative will give me a positive. And then when they add it up together, will give us our negative 15. So our factored version is w minus 2 and w minus 13. Okay, so now you try number 7 and see if we get the right answer. So this is what I got. I've got 6 times 8 is going to give us that negative 48. Notice there's a negative sign and a positive sign. And then when we add those together, it's going to give us a positive 2. So as I mentioned, factoring is one of the most important and most forgotten things, so let's practice some more. Okay, here's what I got for 7 through 12. Hopefully you got something close to that. Remember, practice makes perfect. Perfect practice makes perfect. Okay, so those were all examples of like if the coefficient in front of the x squared was 1, what happens if it's not? So there is a technique of doing this, and this you may or may not be familiar with this. I only figured it out when I started actually working here at Lou High. So when I went through school, I didn't know about this, but it works and it's amazing. So the way this works is you take this 2 and you wrap it up into the 18. So you're going to multiply by the 18. So we've got a new polynomial. We've got x squared minus 15x plus 36. So from there, you factor normally. So I'm looking at 36. Let's see here. 36 divided by 2 is 18. They need to add together to get my 15. So that's not it. 36 divided by 4. Oh, I forgot 3. 4 plus 9 is 13. So we're going to try 3. I just forgot it. Sorry. 36 divided by 3 is 12, which we add those together, we will get 15. But they're both going to be negative because of this negative sign right there. So we factor this polynomial. We got x minus 3, x minus 12. But we still have to deal with this 2 that we wrapped up into this 18. So what we do is when we pull it out, we divide both sides or both second numbers by 2. We reduce if we can, and if we can't, we wrap it up into the x. So this 2 is going to go right there, and this is going to simplify. So what we're going to have left over, we're going to have 2x minus 3, x minus 6. And there you go. It's a surefire technique as opposed to guess and check, which I had to do. So let's try another one. All right, let's do one more together, and then the rest of them is going to be part of our practice work. So again, we've got this pesky little 5. First thing I would do is I would look through and see if I can factor that out. I can't. So we're gonna wrap this 5 up into the 48. Yes, we're gonna have a big number, but whatever, it's fine. So we're gonna have p squared plus 22p minus 240. So now I'm looking for multiples that's gonna subtract together to give me 22. So I have no idea where we're going with this one. So 240 divided by 2 can be 2 times 120. Not anywhere close, so 240. I'm just going to skip to 5. So if we have 5, that's going to be 48. 48 minus 5 is, again, not anywhere close to 22. So 240, I don't know, divided by 6? No. 240 divided by, I don't know, we'll just go 10. I think I went too far. So 10 times 24, when we subtract that together, it's going to be 14. So we're going to go back the opposite direction. 240 divided by 9 is nothing. 240 divided by 8 is 30. Okay. So 8 times 30. And then if we take 30 minus 8, we will get 22. And a positive 22. All right, so we're good to go. So we're going to have p plus 30, p minus 8. But we had this 5 over here that we got to deal with. So we're going to divide both sides by 5 and see if they reduce. So our first one's going to reduce. 30 divided by 5 is 6. I knew that. And then this 5 won't reduce, so we're going to put it in front of the p. 5p minus 8. So there you go. So try the rest of these yourself. We're going to include that in the practice problems that we do in class, and we'll see how it goes. Okay, last factoring review thing is difference of squares. So difference of squares, if you remember, there's actually a formula. So I put the formula up here. So that's if you have a square, a perfect square minus a perfect square, you're going to get this. So this is just something that you do have to remember, memorize. I can give this to you if you ever ask for it. But what you have to do is you have to recognize a perfect square and or difference of squares when you see it. So when we have difference of squares, we just use this formula. So for 21, we've got x squared minus 4. 4 is the same as 2 squared. So we're going to have x minus 2, x plus 2. And it's easy as that. So like 22, we've got a y squared and 81. 81 is a perfect square. It's the same as saying 9 squared. So our answer there is going to be y minus 9, y plus 9. So it's as easy as that, but the challenging part is recognizing that this is a square. Generally, what I do is if I see a squared and a minus sign, that is my trigger to think about, gee, is this a perfect square? And if you don't recognize that this is a perfect square, use your calculator, just go, 3 squared, 4 squared, 5 squared, and see what those numbers are, and see, you will eventually find that 9 squared is this 81. So that's kind of my strategy. Again, if you see a squared and a minus sign, there's a high probability that you could be looking at a difference of squares. The same is true when you have variables. It doesn't change the pattern. It just kind of changes what you end up writing down. So this right here is the same as saying 3x squared. And this is the same as saying 5y squared quantity squared. So it is still a difference of squares. It's just going to look a little bit more complicated. So our answer is going to be 3x minus 5y and 3x plus 5y. Squared. From that squared right there. So again, with variables, it's the same pattern, just gets slightly more complicated. So over here at 24, the left term right here is the same as mn squared. I hate it when they put m and n together. And 49 is the same as 7 squared. So then when we do our difference of squares, we're going to have mn minus 7, mn plus 7. So the last two, I want you to try yourself and see if you get the right answers. So this is what I got for 25, 26. Note that they get a lot easier if you factor your greatest common factor out first and then do a difference of squares. So hopefully this makes sense. We'll try some more in class. I'll see you there.